Welcome to our another session. So today we are going to discuss another technique in our design and analysis or analysis and design of algorithms, that is called as space and time trade-off. Right. So till now we have discussed various techniques in our this particular course. So starting from brute force till the recent one, that is the greedy technique we have seen, dynamic programming we have seen in the previous section. So today we talk of another important technique called a space and time trade-off. So now basically what do you mean by the space and time trade-off? So let us try to understand this before we try to take up some examples and try to work on that particular examples. See, whenever we are given a particular problem to solve, so we know that there is certain input, right? So we have some input of our problem. So now when an input is given for us, now you try to pre-process this particular input. So what is the basic idea behind this space and time trade-off technique says is that is to pre-process. So whatever input is given for us to solve the problem, now that input itself we are going to pre-process the input. We are going to check the input properly, observe the input properly. Can we extract some additional information from the given input? Right, so we are going to extract certain additional info. Say that by pre-processing the input of our problem and trying to store that as an additional information, it helps us in solving the problem. That is what the space and time trade-off says, or this approach is also called as input enhancement. So you are going to observe the input carefully and try to see that is this input, can we extract some additional information from this input so that it helps us to solve our particular problem. Clear? Now here, we have got certain examples which will be trying to do this or trying to consider this in this particular section. Now another technique, so one is input enhancement. Now another technique is that uses space and time trade-off. When we are talking about this, one is observing the input. The second one is it suggests that using extra space, right? So the title, the course is space and time. So if you are going to use some extra space, right? So now when we are going to use an extra space, it facilitates faster, or it will be more easy for us to solve the particular problem if we are considering the space here. So obviously we say that whenever you are designing an algorithm should take less space so that it executes very fast. But here we say that sometimes for certain problems, if we compromise the space, that is what trade-off it says. If we try to compromise the space, then obviously it really helps us to solve the particular problem. So now that approach is called as pre-structuring. So basically our hashing comes under that particular way, that is pre-structuring. So now let us consider an example of sorting. So sorting by counting. Now here what we try to do is, in this method we are going for input enhancement. There is an application of input enhancement. Now here we will count the number of elements smaller than each element, right? So now say for example an array is given. So how many numbers are given for us? 1, 2, 3, 4, 5 and 6, right? So 6 numbers are given for us. It is stored, let us say that it is stored in an array, and you know that array first element, the index element will be from 0 to 5. So you have 0 to 5, that means totally 6 elements are stored in this array. Now one easy method is that now you want to sort this array in ascending order. Now what we say is that count the number of elements smaller than each element, right? You make a count. Now this count is stored in a table and it indicates the position of that element in the stored list. So you count the elements which are smaller than that particular element and that value or gather that value in a table, right? And that value will indicate the position in which the element are to be stored in the sorted list. So this algorithm we call it as the comparison sorting. So we call it as comparison sorting. It is very, very simple. Okay. Now let us take this example as we are telling. Now we have got an example. Now we want to sort these 6 numbers in ascending order. Now what does the logic, what does the comparison counting tells us? So first start with your first element 5. So what is the first element is there in our array? Now the first element is 5. Now you count how many elements are less than 5, right? So in our entire array, how many elements are less than 5? You make a comparison. Now you start with here. Now 3 is less than 5. Yes, now we have one element which is less than 5. Now what about 2? 2 is also less than 5. So now we have two elements. 6 is greater than 5. Leave it. 1 is less than 5. So there is 3 elements. 4 is less than 5. There is 4 elements. So totally we have how many elements? There are 4 elements. Now we are going to enter this. We store this additional information. See here, what does the input enhancement technique says that no, the only for us input is an array, but we are now collecting an additional information. Now what is that additional information? First element, each element, how many elements are less than that element, we try to count it. So less than 5 in our array, there are totally 4 elements are there. Now take the second element 3. Less than 3, how many elements are there? 5 is greater, leave it. 2 is less than 3, so 1. 6 is greater, leave it. 1 is less than 3, so 2. 4 is greater than 3. So how many elements are less than 3 in our array? There are 2 elements, 1 and 2. So we write it that there are 2 elements less than 2. Clear? It's very simple, straightforward. Similarly, less than 2, you have 1 element. Less than 6 in array, you compare all elements in an array and check how many elements. You have totally 5 elements less than 6. Less than 1, no elements, that is 0 elements. And less than 4, you have 3 elements, right? So now what we have done, so we have made a count and we have counted that elements, we have counted the number of elements smaller than each element. Clear? Now we have written it in a table. So now what we do is that we take these values, this pre-processed value. So now less than 5, how many elements are there? 4 elements. So now we take this 4, right? We take this, now this values will be the index. So it will be index. So we can say that this will be the index in your resultant array. Suppose say that this is your resultant array, that is sorted array. Now this value will act as a index. So you go to the 4th index, right? So now this 4 correspond to which number? 5. There are 4 elements less than 5, right? This 4, it corresponds to this 5. So now we take this element 5, we place it in the 4th position of our sorted array. So this is our 4th position. Now in this 4th position we write 5. Clear? Take the next one. If you are not clear, now again listen carefully here. Now there are 2 elements less than 3. So we take this element 3, right? How many elements are less than 3? 2. We go to the index 2. Now in this place 2, we write that element 3. Very simple. 2. Third element is 2. How many elements are less than 2? 1 element. We go to the index 1 and we enter 2 here. 6, element 6. There are 5 elements less than 6. Go to index 5. Which element it corresponds to? It is 6. Right? Then 1, element 1. There are 0 elements. So go to the index 0, write that element 1. Take the next last element 4. 3 elements are less than 4. So go to index 3 and write the element 4. Now you read this array. 1, 2, 3, 4, 5, 6. It is sorted. Right? Wonderfully it has been sorted. Now see, you got the result. You had an unsorted array. Now you have sorted it in ascending order. So this method we call it as comparison sorting. Right? Here our input enhancement. So what is that extra information we are deriving from the given input? This is the extra information. Right? Now how can we design this in our algorithm? So now what we are doing here is that input is the given array a to n minus 1. We are going to sort it by comparison counting. Right? What is the output? So sorted array. So first we are going to count. So we take an array count, right? A single dimensional array count. So we initialize this to 0 for I equal to 0 to n minus 1. Initially we will initialize this count to, let us see that how we are going to, how that count variable has been increased here. So what we are doing, so for I equal to 0 to n minus 1, so we initialize this count to 0. So then for I equal to 0 to n minus 2, now we are supposed to compare, right? So since we have to compare one number and the second number, so if you start with 62, let's say this is another example, we should see that how many numbers in our given array are less than 62. We are going to keep that in our count. Clear? So now what we do, we have to compare that with the next element. So for I equal to 0 to n minus 2, for j goes from I plus 1 to n minus 1. Now what we are going, if a of I is less than a of j. Now initially I is 0, right? So initial I is 0. What will be the j value? 0 plus 1, 1. So you are going to compare a of 0 and a of 1. That is, you are going to check that what is our condition here? Less than. So we check 62 less than 32. If it is yes, we increment count of j by 1. That is this index j we are going to use. Otherwise, we increment this count of I by 1. Right? So because here I and j are the two variables what we are going to use. Now you see here, first time and the first pass initially, now what will be there in our array count? All will be 0. We have initialized this to 0. So when I is 0, right, when you start initially I is 0, what will be j? J will be 1. So we are going to compare is 62 less than 31. Since 62 is not less than 31, so we go to the else part and count of I is assigned to count of I plus 1. Now what is count of I? So in count of I is 0. Count of 0, what value is there? Previously we were having 0. Now 0 plus 1. Now this becomes 1 here. Now this becomes 1. Right? So then j is incremented by 1 again. Now j becomes 2 here. So now you are going to check a of 0 and a of 2. Right? Now 62 less than 84. Yes. Since 62 is less than 84, so now count of j. Now j is 2, right? 0, 1, 2. This is the index 2. So now that value will be incremented 0 to 1. Clear? Again j is incremented. Next step we are in the j loop. So now we go here. So like this, what happens we are trying to do in this particular for loop is that once the complete 4 passes are completed, so now when you are going to start with the first number 62, the count value will be 3. That means there are 3 numbers which are less than 62 in our given array. Right? So when the entire loop has been completed, now this is the value what we are going to get. So we are going to get 62, there are 3 numbers less than 62, 31, there is only one number which is less than 31 in our given array, except similarly respectively. So then we take this as an index, right? We take this as an index, like say now element 62, there are 3 elements less than 62, so we go to the index 3, 0, 1, 2 and 3. Now in this particular place we will write 62 comes here. Clear? So like this, now we are going to solve this particular problem, or we are going to sort the given array. Clear? So now if you want to do the analysis of this algorithm, now what is the time complexity? We know that C of n will be equal to, now there are 2 for loops. So for one is summation I equal to 0 to n minus 2, another one is j is equal to I plus 1 to n minus 1, and we have only one comparison, we will write 1, right? This is equal to, so now we remove this summation. We have done lot of problems like this, right? So we will remove this summation, upper bound minus lower bound plus 1, so right, upper bound minus lower bound plus 1. When you simplify this, we will get n minus 1 minus I. Now remove this summation, you substitute value I as 0, so from 0, 1, 2 etc. up to n minus 1, and when you simplify, you will get n into n minus 1 by 2. Now as n increases, right, so now we can say that the time complexity of this particular we can try to find, right? So this is n square. So this is how now we are going to do the analysis of that. So we can say that belongs to n square, theta of n square, because n into n is n square, highest order term is n square. So this is one type of a sorting, now which we call it as sorting by comparison. Clear? Now there is another way in which we can try to do the sorting, which is called as distribution counting. Now, especially when we are talking about distribution counting, we cannot sort all type of inputs. Now here, now we are going to use some concept of our statistics and try to sort the given array. Now basically, what type of input should be there? Now you should have the input. So always when you are going to consider the numbers, now always that number should belongs to some set. Say for example, now an array is there. Right, we are going to sort this particular array. Can we apply the distribution counting? Now before applying, you have to see that what all these numbers are there. Now you can clearly observe that the numbers are 13, 11, 12, 13, 12, 11, 13, like this only it is coming. That means now all these numbers are derived from this set of numbers. If you are if we are having some numbers from one particular set, so like say if you consider a set, say for example, now if you consider a set 1, 3, okay, 3 and 4. If this is our set, now the array, all the numbers in our array should be only 1, 3 or 4, not other number. Like you can have an array with the elements 1, 1, 4, right? Again, right? 1, 4, 3, like this. The numbers in our array should belongs to only this set 1, 3, 4. Then only we can apply distribution counting here. So now say here, now if you take this example, now we have got all these numbers comes in the set. What is that? 11, 12 and 13. So you have 11, we have 12, you have 13, and should not be overwritten in the process of sorting. We are not going to overwrite this. So that now what we do in distribution counting is that now first thing you have to find the frequency. Now what we do, now we will write down the set of numbers. So what are the set? 11, 12 and 13. That means all the elements in our given array for sorting, it will be either 11 or 12 or 13. Right? So you write that number and first you find the frequency. Now what is the frequency? Is that like frequency of 11. How do you find what is the frequency of 11 in this given array? The frequency means the number of times this 11 occurs in our given array. How many times 11 is occurring in this particular given array? Only one time 11 is occurring. Right? Only one time you have got 11. Now what about 12? You check 12, how many times you count it here? 1, 2, 3. So totally 3 times 12 is occurring in our given array. So what is the frequency of occurrence of 13 in our array? 2. So 2 times 13 is occurring. So first step what you are going to do, now you are going to find the frequency of this array. Now once you find the frequency, the second task what you are going to do is find the distribution value. Right? Now how do we find the distribution value? So now the distribution value, the first value we start whatever is written in the frequency. Right, now frequency 1 is there, we consider distribution as 1. We start with the same value. The next distribution is by adding this 1 with the next value of our frequency. Right, so now what is this? So this next value in the frequency table is 3. So 3 plus 1 you get 4. Next again 4 plus 2 is 6. Right, so in this fashion we are going to find the distribution. So once you have got the distribution, now how we are going to process this array? Right, now let us say that this is our array. So how many elements are there? So you are given array 0, 1, 2, 3, 4, 5. So totally the 6 numbers are there. So these indexes we will write 0, 1, 2, 3, 4 and 5. Now this table, now this is our distribution table. Right, so distribution table index is 0, 1 and 2. Sorry, this is 2. Right, now what is the, now how we try to do this? So we start from the reverse order. We start from the last number, right? Now this is your input array. Now we start from the last value. So what is this last value? So this is 12. That's a of 0. So last number is 12. A of 5, right? A of 5, that is the sixth number. So a of 5 is 12. So we take that last number 12. Now this, what is this number? So this element is 12. Now you see what is the distribution of 12. Now this is the distribution. So this is the distribution 1, 4, 6 from our distribution table. So 1 is for number 11, 4 is for number 12, and 6 is for number 13. Right? 1, 4, 6. You can see here 1, 4, 6. For 11, element 11, distribution is 1. For 12 it is 4, and for 13 it is 6. We will write it here. So now you start with the in reverse order from right side. So a of 5. So a of 5 is how much? So it is 12. Clear? A of 5 is 12. So now you are going to look into the distribution for 12. So for 12, what is the distribution? So distribution is 4. Right? So we take that distribution 4, you subtract 1 from that. 4 minus 1, which is equal to 3. Right? 4 minus 1 is 3. So now this will be our index in this particular array. So you will go to index 3, 0, 1, 2, 3. Now in index 3, you are going to write this number 12. So 12 is written in this index. We write the number 12. Clear? So now we go to the decrement this by 1. So we go to the a of 4. So next number. Next number is also 12. Right? So now you check your distribution table. Now the value is C. Previously distribution for this 12 was 4, but now you have subtracted 1. So what is the result? Now it will be 3 here. Right? Now again the number, again this next number is also 12. So again look into what is the distribution value for 12. It is 3. Subtract 1 from that. 3 minus 1 is 2. Right? Now you will get the value as 2 here. This is a new value in our distribution table. So again it will be 1, 2 and 6. Right? Now what value you got? 3 minus 1 is 2. Now you go to the index 2. So you go to the index 2, and what was this number? 12. So we will write 12 in the index 2. Clear? Then decrement by 1. You go to the next number is 13. Check the distribution value for 13, which is 6. So now what you have to do? Decrement it by 1, subtract 1. So 6 minus 1 is 5. So 6 minus 1 is 5. So you go to the index 5 and write that number 13. Clear? So the next time, what is the updated distribution table you will be having? 1, 2 and 5. Because 6 was there, now you subtracted 1, 5. Take the next number. It is again 12. Distribution of 12 is what? 2. So you have to subtract 1 from this. So 2 minus 1 is 1. You go to index 1 and write that number 12. Right? Now what is the distribution table you have got? Now 1, 1 and 5. Next number 11. For distribution value for 11 is 1. So what you have to do? 1 minus 1, 0. You get 0. So right, you get 0. Now go to that index 0. Write this number 11 here. Now we come to the last one, 13. So distribution for 13 is 5. Right? So now distribution for 13 is 5. So 5 minus 1 is 4. So you go to index 4 and you write that number 13. Clear? Now by this time what has happened, if you look into the array, if you this array properly, what is the first element in this array? We have 11. The second element is 12. The third element is 1. The element is 12. The element is 13. And the last element is 13. So your array is sorted in ascending order. Okay. Now this we call it as a distribution, what is called distribution counting. Distribution counting. Right? Now this is the entire thing. Now what manually we have done, now they have given an algorithm. Right? Now what does the algorithm says? First we start with a loop for j equal to upper bound minus lower bound. Now what is the upper bound minus lower bound? So if you take your values, so the set is 11, 12 and 13, right? So we can take this as your lower bound 11, and you can take the upper bound 13 as your upper bound. So for j is equal to 0 to upper bound minus lower bound, that means 13 minus 11. So you will get how much? 2. Okay, you get 2. So that is you are having 0, 1, 2. So that is you have 3 numbers. So now you are going to find you initialize the frequency of all this with 0 initially. So initially it is 0. So next for I equal to 0 to n minus 1, what we do now, we are going to see now a of I minus 1, a of I minus 1. Now that subscript value you put that in D, you are going to put that in D plus 1. So we try to compute the frequencies. Now you take our array, given array, you take one by one number, right? So you are going to take this number, like say first number is 13, right? So you take that particular number for I equal to 0 to n minus 1. So you take that particular number 13. So now this a of 0 is 13. So now 13 minus 1, right? So you are going to find 13 minus L, this is 13 minus lower bound. Now 13, the first element was 13. What is your lower bound? Lower bound is 11, right? So 13 minus 11 is 2. So 13 minus 11 is, you get 2 here. So in D of 2, so distribution table if you consider, so D of 2 corresponds to this element index. You are going to go for this index. Now for this index you add 1 to this. So that means, see, previously it was 0, now you are going to add 1, right? So now this is your frequency table. So how many numbers are there? The first one is 11, 12, 13. So first element was 13, so now this becomes 1. That means 13, there is one number. Then we take the next element. Let us say next element. So the next element in 11, right? Now see how beautifully we will find out. The next element what we are having in our array, now it is 11. Now 11 minus of lower bound. So what is lower bound? Lower bound is 11. So 11 minus 11, you get value as 0. So in this frequency table, you go to the index 0. To this index 0, you add 1. So this becomes 1. So that means 11, now one number is there. So previous number was 13. So here it becomes 1. Now 11, 1 we got. If the next number is again 11, we'll go to this index and we'll increment this by 1. So this becomes 2. So like this, so this for loop computes the frequency. Once you have got the frequency, so then you compute the distribution for j is equal to 1, 2. Right? So now when you have got the frequency here, already this you got. Once you have the frequency, you have to find the distribution. Now distribution you start with 1, right? So we are using same array. We are not using another. No, we are not taking another array. We take the same array, in that only we find the distribution. Now we start from 1 here. We don't start from 0. Why? Because the first distribution value is same as this value 1. So we start from this value 3. Now 2, 3, we are going to add the previous number. So 3 plus 1 will get 4. Just like Fibonacci series, how we have done, right? So now you will get 4 here. So now instead of 3, 3 is 4 written with 4 now in the same array. So next number, so you should get what you are going to take. You take this value 4 and add this to this, the next element. So 4 plus 2 is 6. Now 2 is 4 written by this 6. So that we are going to find the distribution table. So here we are doing that. Previous number plus next number. Here. Then the final step. So what we do? So for I equal to n minus 1 down to 0. That means we start from reverse, from the right side. Clear? Now we have to start from the minus lower bound. So we subtract the lower bound, we get the J value. Right? So we get index and we go to the distribution table and we are going to subtract 1 and you get the index. So now the array element you put it into the final array, that particular index. Clear? So this is how now we try to do the another way of sorting, which is called as distribution counting. But you cannot apply distribution sorting or distribution counting to all arrays. Let's say, for example, when we are this 1, 2, 3, 4 for this one, you cannot apply distribution counting for this. So it should be very, very special cases only you can apply the distribution counting. Okay. So this was the one example what we have seen now, which is called as the distribution counting. So in the next topic now we are going to look into the input enhancement in string matching. So we will take another example. Now we are going to consider an example of a string matching and we will try to see one important algorithm. So now already we have defined what is a string matching problem in our brute force technique, right? We have seen how you, when a text is given and when a pattern is given, how you are going to compare the pattern in your given string. Clear? In our brute force method we have solved that problem. We will take the same problem here and we, by using space and time trade-off, now we are going to use some of the one important algorithm which is called as the horse-pulls algorithm. Right? We will try to understand that particular algorithm in our next topic. So till then, so you practice both of these algorithms, right? If you have got any doubt, anyhow it is very clear. So what the overall, what the concept says, time and space trade-off, right? What it says, when an input is given, you try to observe the input carefully and extract some additional information from that input. Are you able to get some additional information? If you get that additional information, you store that and take help of that additional information also to solve the problem, right? So that is what the this particular technique says. So if you have again any doubts, you can drop the queries in the classroom. So thank you. Bye bye.